Now, in continuation to the previous video, we will study in this session about the chemical reactions of alcohol, phenol and ether. Now, alcohol, they are versatile compound. They react both as a nucleophile as well as electrophiles. So on the basis of these, on the behavior as a nucleophile and electrophile, we will study the reactions of alcohol and phenol. The first is the reaction involving cleavage of OH bond. Cleavage of that is this bond. So under it, first we'll study that is reaction with reactive metals like sodium. So when alcohol reacts with sodium metal, it forms alkoxide. Sodium alkoxide and liberate hydrogen gas. Now since in this reaction hydrogen gas is liberated, this shows that alcohol is acidic in nature. Alcohol is acidic in nature. We can take the example tertiary alcohol. In tertiary alcohol, it reacts with sodium. Again, it will form that is tertiary alkoxide. When phenol reacts with sodium, here we can also take other metals also like aluminum, magnesium. I am taking the example of sodium. It forms sodium phenoxide and hydrogen gas. In addition to this, phenol also reacts with aqueous NaOH it forms again sodium phenoxide and water molecule. So the above reactions which you have studied of alcohol and phenol, it shows that they both of them are acidic in nature and they behave as Bronsted acid. They behave as Bronsted acid. Now what are Bronsted acids? Those acids which can donate a proton. Those acids which can donate a pair of electrons. Next is acidity of alcohol. Next is acidity of Now, the acidic character of alcohol is due to the polar nature of OH bond. Due to the polar nature of OH bond, and electron releasing alkyl groups are attached to the oxygen, which increases the electron density on the carbon, which increases the electron density on oxygen atom, and due to which the polarity of the bond decreases and liberation of proton is easy. Now this R is electron releasing. So the R is electron releasing. It increases the electron density on this carbon then to this oxygen. So the polarity of this OH bond decreases, due to which the liberation of proton is easy, you can say. So the primary alcohol is better acidic than secondary and then tertiary. Now next, comparison of acidic character of alcohols with water. Now alcohols are weaker acid than water. This we can explain on the basis of this reaction. Alkoxide plus water, it forms alcohol and the nucleophile. So this reaction shows that water is a better proton donor. Water is a better proton donor. It donates the proton to alcohol. Therefore, water is better acid than alcohol. Next is, so here we can say that alcohol behaves both as well as proton donor as well as proton acceptor. In this reaction you have studied that it is proton acceptor. Earlier when it reacts with sodium, it donates the proton, so proton donor. So it behaves both as well acid as well as base, bronzed acid as well as base. Now acidity of phenol. Phenol is acidic in nature, and the OH group is directly attached to the sp2 hybridized carbon of benzene ring, which benzene ring is electron withdrawing group, and due to which the oxygen acquires positive charge and liberation of proton, again here it is possible. So phenol is acidic in nature. Now when we compare the acidic character of phenol and alcohol, then phenol are better acidic than alcohol. Phenol are better acidic than alcohol. Next is esterification. Now, what is esterification? When alcohol reacts with carboxylic acid in the presence of acid, it forms ester. When carboxylic acid reacts with alcohol in the presence of acid, it forms ester. And this is a reversible reaction. We can use this reaction can also takes place with phenol also. For example, so this reaction takes place both with alcohol as well as phenol. Now, in place of acid, we can also take acid chloride. This reaction takes place in the presence of pyridine. It forms yes. So this reaction takes place in the presence of pyridine. So to neutralize HCl which is formed in this reaction. That is function of pyridine is to neutralize the function of neutralize the effect of HCl formed in this reaction. We can also take acetic anhydride CH3CO whole twice O. This is acid chloride. Already you should know the name of these compounds, and while writing equations always practice to write down the name below it, then it will come in your habit, then you will never forget to write down. Again, only the difference is byproduct formed is acetic acid. Now, one more reaction here we'll study, that is acetylation of salicylic acid. acetylation of salicylic acid. Now, acetylation of salicylic acid. Salicylic acid is 2-hydroxybenzoic acid. 2-hydroxybenzoic acid is only called as salicylic acid. When it undergoes acetylation, that is, when it reacts with acetic anhydride in the presence of acid, it forms acetyl salicylic acid. Acetyl salicylic acid. Commonly it is known as aspirin. Aspirin is used as a painkiller, or you can say it is used as a mild reliever for fever also. The doctors also provide this medicine to dilute the thickness of the blood, so the patients who are suffering from heart attack or hypertension can use this medicine. Next is reaction due to the cleavage of carbon oxygen bond. Next is reaction due to the cleavage of this one, cleavage of carbon oxygen bond. So under it, first we will study, that is reaction with hydrogen halides. Reaction with hydrogen halide this reaction we have studied in chapter haloalkane and haloarine. When alcohol reacts with hydrogen halide in the presence of anhydrous zinc chloride, it forms alkyl halide. When alcohol reacts with HX in the presence of anhydrous zinc chloride, it forms RCl plus H2O. This anhydrous zinc chloride and concentrated HCl is known as Lucas reagent. Now this reaction is used to distinguish between primary, secondary and tertiary alcohol. Primary alcohol do not give turbidity. Secondary alcohol after 5 minutes and tertiary alcohol immediately. Very important reaction. Question is asked how will distinction between ethyl alcohol and isopropyl alcohol, or tertiary alcohol and secondary alcohol. By name it may be asked, or it may be asked by classification. So you should know primary alcohol do not give turbidity, that is white PPT. Secondary alcohol after 5 minutes, and tertiary alcohol will give immediately. And you should write down the chemical equations. Keep in mind, otherwise the half of the marks will be deducted. So alcohol, this is primary alcohol, you can change here, that is R2COH or R3OH. Next is reaction with phosphorus trichloride. This also you have studied. When alcohol reacts with PCl3, it forms RCl plus H3PO3. If it reacts with PCl5, it forms RCl plus POCl3 plus HCl. Again, in the first chapter we have studied. Next is dehydration reaction. Now dehydration reaction is removal of water molecule. Dehydration when ethyl alcohol undergoes dehydration or heated in the presence of acid, it forms alkene, and removal of water, so it is called dehydration reaction. Now ethanol undergoes rehydration to form alkene. Secondary and tertiary alcohol, they undergo dehydration under milder condition, means the tendency of dehydration is tertiary has got the maximum tendency of dehydration, then secondary, and then primary. So the conditions for the tertiary alcohol will be less milder than more milder than the secondary, than the primary. Now comes mechanism of the reaction. See, I have not told you, that doesn't mean, but only you change the R group and you can write down the same reaction. For example, here we take H2SO4. In the case of secondary alcohol, you can take phosphoric acid. Phosphoric acid is a weak acid. It will also help the reaction. I will give you the example. For example, secondary alcohol. Now secondary alcohol requires only 85% phosphoric acid. It is a weak acid. And here it's a strong acid, then also it requires the temperature of 443 Kelvin. So here now 3 carbon. So alkene of 3 carbon will be formed. In the case of tertiary, only 20% phosphoric acid is used. So by using this reagents, we can conclude that tertiary alcohol undergoes dehydration easily, then secondary, then primary. Now we will study the mechanism of this reaction. Now mechanism of dehydration of ethanol. Now again it also involves the 3 steps. Now step mechanism of dehydration of alcohol. First step is formation of protonated alcohol. Formation of protonated alcohol reacts with the proton it forms protonated alcohol, and this is a reversible reaction. It forms protonated alcohol. Also called as ethyl oxonium ion. Second step, this is step 1. Now second step is formation of carbocation. That is this bond will break. This bond, it will break, so it will form CH3 CH2 plus H2O. This bond will break and the water molecule will eliminate by taking the electron pair of this bond. The third step is deprotonation, that is elimination of proton. Step 3, elimination of proton. So this carbocation, ethyl carbocation will release the proton to form alkene. Next is oxidation reaction. Now the second step I forgot, that is a slow reaction, and slow reaction is the rate determining step. Slow reaction is the rate determining step. Next topic is oxidation. Now oxidation. Now oxidation is, that is alcohol oxidation. Alcohol on oxidation, it forms aldehyde and aldehyde on oxidation forms carboxylic acid. If we use a strong oxidizing agent, then the middle step is escape. For example, if we take K2Cr2O7 oblique H2SO4, or you can also take alkaline KMNO4, then alcohol is directly converted into carboxylic acid. But if we want to prepare alcohol from aldehyde, then we can use the reagent CrO3, that is chromium oxide. We can also use PCC. PCC is pyridinium chlorochromate. Pyridinium chlorochromate. So primary alcohol will give you aldehyde and carboxylic acid containing same carbon atom. Similarly, secondary alcohol will also give aldehyde and carboxylic acid of the same carbon atom, but tertiary alcohol do not undergo oxidation reaction. Tertiary alcohol do not undergoes oxidation reaction. Next is hydrogenation reaction. When primary alcohol undergoes RCH2OH, when it reacts with copper, temperature is 573 Kelvin. It forms aldehyde. If secondary alcohol is taken, reagent is same, copper and temperature same, it will form ketone. And if tertiary alcohol it forms, again same temperature, it forms isobutylene. So primary alcohol and secondary alcohol, they undergoes dehydrogenation from aldehyde and ketone, whereas in the case of tertiary alcohol it undergoes dehydration. Next is reaction of phenol. Now phenol, the OH group present on benzene ring is ortho and para directing, so the incoming group will go to ortho and para position, means the isomers, two isomers will be formed. First is nitration. When phenol reacts with dilute nitric acid, it forms ortho nitrophenol and para-nitrophenol. Ortho nitrophenol and para nitrophenol. Now these two isomers can be separated by steam distillation. Because the ortho-nitrophenol will form intramolecular hydrogen bonding, whereas the para-nitrophenol will form intermolecular hydrogen bonding, and intermolecular hydrogen bonding will increase the boiling point, whereas intramolecular hydrogen bonding will decrease the boiling point of the compound. So there is a large difference between the boiling point of these two isomers. Therefore, both of them can be separated easily by steam distillation. Next is with concentrated nitration of phenol with concentrated nitric acid. When phenol reacts with concentrated nitric acid, it forms 2,4,6-trinitrophenol. When phenol reacts with concentrated nitric acid, it forms 2,4,6-trinitrophenol, and commonly it is called as picric acid. Next is halogenation. Again, halogenation, when phenol reacts with bromine in the presence of solvent CS2 and temperature is 273 Kelvin, we get two isomers, ortho-bromophenol and para-bromophenol. Ortho, that is 2-bromophenol, and 4 bromo phenol. Now, the halogenation of benzene takes place in the presence of a Lewis acid like FeCl3. In the case of phenol, the bromine molecule takes place, the polarization of bromine molecules takes place even in the absence of Lewis acid due to the highly activating effect of OH group. Halogenation of phenol can take easily due to the highly activating effect of OH group attached to the benzene ring. Now, if we replace this CS2 by water, if we replace the CS2 by water molecule, then we get white PPT of 2,4,6 tribromo. If we take this bromine water, then we get 2,4,6 tribromophenol, white PPT. Sometimes if question is asked how will you differentiate the two compounds, this one, carboxylic acid and phenol, and we can use this reaction. When phenol reacts with bromine water, it forms white PPT. So this can be used as a test for phenol. Next is Kolbe's reaction. Kolbe's reaction. Now Kolbe's reaction is when phenol reacts with NaOH in the presence of it forms sodium phenoxide. When phenol reacts with NaOH, it forms sodium phenoxide, which reacts with carbon dioxide, and second step will be acidic hydrolysis. It forms two hydroxybenzoic acid or salicylic acid. Next is Reimer-Tiemann reaction. Reimer-Tiemann reaction. When phenol reacts with chloroform and NaOH, it forms, second step will be hydrolysis. In the presence of acid, it forms salicylaldehyde, OHCHO, and if we replace chloroform by CCl4, all the reagents will be same, then it forms salicylic acid. And last reaction is oxidation. Phenol undergoes oxidation in the presence of sodium dichromate and sulfuric acid. It forms benzoquinone. It forms benzoquinone. So now in this session we have studied the chemical reactions of alcohol and phenol.